Eric Burgess here, and we've been given a sequence 3n over 1 plus 6n, and we are to find the first 10 n's, so n1 through n10, and then determine if there is a limit. And if there appears to be a limit, to first graph the points and then to calculate that limit. So that's what we're going to be doing here. So the first bit's pretty easy, right? For like a1, for example, we just plug in n for 1 because, right, it's an, so n is 1. So we'd have 3 over 1 plus 6 because, right, we just replace n with 1. Now, they want us to do it to 4 decimal places of accuracy. Just for example, a2 is 3 times 2 over 1 plus 6 times 2. And we do this on and on and on. I've actually already calculated those values, so let me go ahead and grab those for us real quick. All right, so here are the 10 values. We could see we start off here at 0.42, and we're slowly going up, 0.46, 0.47, 0.48, and we hang out at 0.48 for a while. These numbers increase, the last two, and then we get to 0.49. So this appears to be going to 0.5. So the limit as n goes to infinity appears to be 0.5. Of this sequence an, it looks like it's 0.5. That's what we think. Now, they asked us to graph it, so I have also already done the graph, so let me grab that really quick. So here is the graph. Now, I chose to go in increments of 0.1. You can do it however you want. And then we could just see it kind of starts out kind of low, right? Because our first one is 0.42 and then 0.46. But we very quickly hang out around the same value and it ever slightly increases. My graph isn't perfect. This looks like it's at 0.5 or even maybe a little bit above. Perhaps this one should be a bit lower. But you get the idea. We're increasing extremely slowly after we go past the first few terms, like from around term 4 on. We're not really moving up. Once we hit that 0.48, we're really, really close to it. So it appears we have a limit. Let's go ahead. Let's calculate this limit. Also for the graph, make sure you label your axes. So, right, we have the output. So this is the an, and then the particular n. So this is n, and then this is an. And that's really all there is to this. You'll pick different scalings according to, right, how much variation you have in your sequence. So let's go ahead and calculate this limit. So again, the sequence is 3n over 1 plus 6n. And one of the techniques that you should be familiar with is just dividing out the highest power of n and the denominator, which in this case is n. So if we do that, we're going to get 3. This is equivalent to 1 over n plus 6, right? If we just divide 3 by n, we divide 6 by n, that gets rid of the n's, and then we divide 1 by n, and so that's why this appears. And now we're in a position where this limit is really easy to take, because if we did this first one, the limit as n goes to infinity of that, we would get infinity over 1 plus infinity, which is infinity over infinity, which is not that useful. So what we're instead going to do is use this other form that is equivalent because it's a bit easier to do. So we're going to take the limit as n goes to infinity of 3 over 1 over infinity plus 6. 1 over infinity, right? It's a huge, huge number. And we're taking the limit at this point. So we plug in an infinity and we see, oh, well, this is a huge, huge number in the bottom, infinity. So it's actually pretty much just 0. At infinity. So we say 0, and we have 3, and we have 6, which is equivalent to 1/2, which is the same thing as 0.5. And so we see that our graphing showed us that, this is correct. It actually does converge to 0.5. For all we know, this could have continued on and on and on forever, just getting higher really, really slow. Like it could have diverged. Now, this is a pretty simple one, so if you look at it, you could kind of do this in your head and be like, nah, this doesn't diverge. But that's the problem with more complicated sequences is the graph might not tell the whole story, so you want to be able to verify it via some analysis. So that is the answer to this. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.